2.5, Section 2. After you read the objective, you can go ahead and do the examples. Let's look at problem number 1. If $5,000 is invested in an account that pays 2% compound interest, compare the amount in the account after 10 years if the interest is compounded semi-annually. So for these problems, you can use the formula, which is the compound interest formula, and just plug in the numbers, or you can use the calculator, and I will use the calculator to solve these compounded problems. So let's enter the letters again. To use the calculator, you're going to press apps, finance, PVM solver, and here are your letters. N is your time, so here your time is 10 years. I is your interest rate, and your interest rate is 2%. So you're going to enter 2% for I. PV is your present value, and your present value is 5,000. Your payment is 0. You have no payments involved. Future value is your unknown. That is what you are solving. P/Y is 1. That's your paying period per year. And C/Y is your compounded periods per year. And compounded semi-annually is twice a year. So let's enter this into the calculator. So N is 10. I is your interest rate of 2. PV is 5,000. You have no payments. Future value is 0 for now. P/Y is 1. And C/Y is compounded semi-annually, so that's 2. So go to future value and alpha, enter, and that is your future value, $6,100.95. So letter B is you're keeping the same time, the same interest, the same present value. Change the future value to 0. P/Y is 1, and C/Y compounded quarterly is 4 times per year. So you're changing that to 4, and future value is alpha, enter. So your future value for compounded quarterly is $6,103. $6,103.97, and that is with your C/Y as 4. So let's move on to C. Again, let's change the future value to 0. C/Y is compounded monthly, and that is 12 times per year. And alpha, enter your future value, and that is your amount, $6,106, with it being rounded. So C/Y is 12, and future value is $6,106. And the last part for number 1 is D, compounded continuous. Change the future value to 0, and C/Y is 1,000,000. So compounded continuous is 1,000,000. 6, and future value is alpha, enter, and that is the future value for the money being compounded continuously. So here for D, you're changing C/Y to 1,000,000, and your future value is $6,107.03. So $6,107.01. I'm sorry, 1 cent. Okay, so now let's move on to number 2. Number 2, you are saving for a down payment on a house and plan to buy the house in 5 years. How much would you need to invest in an account that pays 4.5% compounded monthly in order to have $10,000 for your down payment? So let's change the letters here, again, you're going to apps, finance, TVM solver. N is your time. So your time is 5 years. Your interest rate is 4.5. PV is what you are solving for. Your down payment is your present value. So you're solving for that. You have no payments. Future value is 10,000. P/Y is 1. And compounded monthly, C/Y is 12. So alpha, enter your PV. And there your present value is $7,988.52. And again, those are all your numbers for number 2. Moving on to number 3. To accumulate $20,000 on your daughter's 18th birthday, how much must you invest on her 2nd birthday in a CD paying 4% compounded quarterly? So again, we're using the TVM solver. N is your time, and now here the time is, so you want to accumulate that amount for her 18th birthday, and you started in her 2nd birthday. So here you have 16 years of investment, which is the 18 minus 2. So you have 16 years to invest that money. I is your interest, which is 4%. PV is 0. You don't have payments. Future value is 20,000. Is what you want to accumulate. 20,000 is your future value. P/Y is 1. And C/Y is compounded quarterly, which is 4. So now going to your present value, alpha, enter, and that is the amount that you need to invest in the present. So PV is $10,579.43. And again, these are all the amounts given. And that completes section 2 for chapter 5.